Hello everyone and welcome to the channel. I am Mayank Lakhotia, Assistant Professor in CSE, AI and ML in Kite Deemed to be University. In this video, we are going to master NumPy with Python. If you ever tried to crunch massive datasets in standard Python and felt like your code was crawling at a snail's pace, you are not alone. Standard Python is a fantastic language, but when it comes to heavy computation, it has a major speed limit. Today, we are unlocking the ultimate performance engine for Python data science. Let's dive right into the slides. First slide is NumPy with Python. Here we done the know about the introduction. To truly understand the power of NumPy, we just need to look at the ecosystem. But on top of it, NumPy is the fundamental engine running underneath the biggest name in Python, whether you are analyzing tabular data with pandas, building machine learning models with skit-learn, developing deep neural networks with TensorFlow, and by PyTorch or by processing images with the OpenCV. SkyPy, NumPy is the common denominator making all of the that computationally possible. Let's move towards the next slide. Here, the bottleneck of the standard Python. Let's look at exact we are trying to solve. Imagine you have a simple task. Increase a list of temperature by 5 degree. The standard Python approach forces you to write a loop, processing each number element by element at a massive scale. This creates a huge performance bottleneck, but the help of NumPy promises changes everything. By converting the data into a NumPy array, you bypass standard Python loops entirely. It executes the math simultaneously across the whole dataset using the highly optimized background C code. Now move towards the next slide. We are having the paradigm shift list versus array. This brings us to a major paradigm shift list versus array. They might look similar on the surface, but their behavior is completely different. Python list chain data together. If you use the plus operator on two list, it simply concatenate means it joins the two lists together into one longer list. NumPy array on the other hand performs math element wise through a concept called vectorization. If you add two arrays together, it automatically adds the corresponding value mathematically, which is exactly what you want. When combining something like monthly sales record, it works. Now in next slide, anatomy of the n-dimensional array, ND array, it is also called as ND array. So what does NumPy array actually look like? They scale in dimensions depending on complexity of your data. A 1D array is a vector representing a flat line, as you can see, of data like single row of the student marks. In a 2D array is a matrix like exactly like an Excel sheet. You have using Excel sheet with your in your systems. It is look like Excel sheet only, structured SQL table with the rows and column. In the 3D array is a tensor, which is we use for complex layered data sets like image collection, medical MRI scans, or video frames. Now moving towards the next slide where we explaining towards the array profiling, the diagnostic dashboard of the array we can use in creating the NumPy. Whenever you are working with a dataset, NumPy give you a built-in diagnostic dashboard to understand your array structure. You use .ndim to confirm the exact number of dimensions you have. With the help of NDIM, we can know the how many dimensions we are having in the our array or in our array. You can use dot shape to see the exact geometry telling you preciously how many rows and column exist in your array. Now moving towards next, we are having dot d type. To check the data type, remember NumPy requires homogeneous data, meaning every element in the array must be this exact same type of the background C optimization to function properly. Now moving towards the next, we are having initializing the canvas. How can we initializing this? All the things before analyzing our data, we often need to generate a blank canvas. NumPy makes initialization incredibly fast. You can use np.zeros or np.ones to initialize baseline matrices like 1000 new accounts with zero balances. If you need a specific default value, np.full will work. Fill an entire specified shape instantly. For sequential data, np.arrange is the high speed equivalent of Python range and functions. And in next, np dot line space is incredibly used for creating even spacing like simulating sensors reading taken at the perfectly even intervals over a timeline. And now moving towards the next slide where we know about the indexing and slicing part of the in the precision targeting, indexing and slicing will now we know about it. Once our data is loaded, you need to extract specific insight using indexing and slicing. Exact indexing lets you target a specific coordinate like querying exactly week 0, day 1. Slicing lets you curve out chunks like extracting the entire first 2 weeks of the data at once. And negative indexing lets you instantly grab the very last row of your data without needing to calculate the total length of an array. Now in the next we have to know about the vectorization mechanics. Vectorization mechanics, the stamping press. Now we get to core magic. Vectorize mechanics thinks of this is a massive industrial stamping press. With NumPy, you can add multiple or square entire dataset simultaneously. If you want to increase an array of 1 lakh salaried by 10%, you simply multiply the array by 1.10. The operation happens instantly with no loops written and zero loops executed in the standard Python. This will work in the vectorization mechanics. Now moving toward the next slide, that is about the statistical engine in the NumPy. The statistical engine, because of this incredible speed, NumPy serves as the ultimate statistical engine. Aggregating millions of records into actionable metrics requires exactly one line of code. You can find the average with the np.mean, get the cumulative total with the np.sum, find peaks and valleys np.max and np.min. You can find the maximum of the peak and minimum of the valley, or measure data consistency using np.std for standard deviation. Moving towards the next slide, data shape shifting and filtering. In the real world, data is rarely in the perfect shape when you receive it. NumPy allows for instant structural shape shifting. You can easily reshape to convert a flat list of raw records into an organized multi-dimensional tables. Furthermore, you can use Boolean filtering to instantly isolate data, like finding all the customer age over 18, bypassing a conditional directly into array brackets, entirely skipping the need for if statement and loops that we are using that makes our code heavier. Now moving towards the next slides that makes the foundation for our AI. The metrics, the foundation of AI. For those of you studying AI and machine learning, this slide is crucially 2D arrays or matrices are the absolute foundation of artificial intelligence. The np dot function which perform matrix multiplication is the core engine behind AI. Modern neural network are fundamentally just massive chained sequence of these matrix operations. Training them in standard Python would be computationally impossible without optimizing execution of NumPy. Now moving towards the next slide where we know about the application, the data science dashboard. Let's look at a real world application. Our data science dashboard. This is exactly how analysts process millions of corporate records by treating a dataset in a single array. They can calculate total revenue, average order value, and peak sales days with zero explicit loops, updating visual dashboards in milliseconds. Now in next we know about our second application that is on image processing. The second application is image processing. An image on our computer is fundamentally just an n-dimensional array of pixel values. If you want to apply a brightness filter on to an image, you are not doing complex graphic designing magic. You are simply applying basic numpy array addition, like adding 50 to every row pixel number simultaneously. Now moving towards the next slide. Under the hood, why is NumPy up to 50x faster? Everyone knows Python is for data science and we knows very fast processing. So we are using the NumPy. So what is happening under the hood to make NumPy up to 50 times faster? Standard Python lists suffer from scattered memory references. Every object has type overhead, causing massive memory bloat and slow CPU iteration. NumPy, however, uses contiguous memory blocks because it enforces uniform data types. NumPy packs of data cleanly together. The result is in a smaller memory footprint, instant CPUs, cache retrieval, and hardware level vectorization written in pre-compiled C code. Now moving towards the next slide where when you know about this synthesis, the high speed, the high speed numeral engine speech to synthesize everything we have covered. Mastering NumPy comes down to a simple three-step high-speed numerical pipeline. First, create your canvas. Second, shape and slice your target. Third, compute using vectorization, math, and statistic. This is the 80 by 20 rule. NumPy, if you can master this pipeline, allowing you to operate on millions of numbers at once without loops. You have mastered the backbone of modern Python data science. I hope this breakdown give you a solid understanding of why NumPy is so essential for data science and AI. If you found the lecture helpful, please hit the like button, subscribe to the channel, and drop any question if you have any in comments below. Thank you for watching this video. I will hope see you in the next session. Thank you.